Welcome to the MS SQL Tips webcast, Best Practices for Migrating SQL Server 2008 to Azure, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast host. Our speaker today is Dave Bermingham. Dave is a Microsoft Cloud and Data Center Management MVP and a technical evangelist at SIOS Technology. And today he will discuss things you should be aware of when migrating to Azure, as well as end-of-life support for SQL Server 2008 and 2008 R2, and how Azure can extend Microsoft support for these versions of SQL Server. Before we get started, if you have questions, you can submit them any time during the webcast by entering your questions in the question area in your presentation controls. We will try to answer as many questions as possible during today's webcast. If you're not already a member of the MS SQL Tips community, we invite you to join. You go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's webcast. So at this time, I'm going to turn things over to Dave, and he can get started.
Great, thanks, Greg. So as Greg mentioned, my name's Dave Bermingham. I work for SIOS Technology. I've been with SIOS for coming up on 15 years now in many different roles, currently senior technical evangelist. I've been product manager, sales engineer. But essentially at SIOS, this software company that has a focus on high availability and disaster recovery, I've been able to really focus and become an expert in those areas of high availability and disaster recovery. And because of that, in about 2009, I was nominated to be a Microsoft Cluster MVP. I held that for about 6 or 7 years, and then most recently they transitioned us into Cloud and Data Center Management MVP. So my expertise is in Cloud, Data Center, and high availability. So this topic is right up my alley. So we're here to talk about best practices for migrating. I'd say migrating, but also running SQL Server 2008 in Azure. And it's like, well, why are we talking about this today? So Microsoft made an announcement this summer that with SQL Server 2008 or 2008 R2 coming end of life in July 9th of 2019, that they were going to allow you to extend that. And most of the messaging I saw early on was about if you move your SQL Server 2008 or 2008 R2 deployments to Azure, we're going to give you some extended support for an additional 3 years. So why is having the support, or really the updates important? It really comes down to security. You don't want to have a SQL Server deployment that has a known vulnerability, and obviously compliance. You have to make sure that you're running software that is secure. So you want to make sure that you don't put your business at risk. So why wouldn't you just upgrade? I mean, SQL Server 2008 R2 has been out for quite some time, 10 years. I was thinking in my mind and talking to some people, these are some of the reasons people don't upgrade. License cost of upgrading, or you have to support a legacy application, or there's just too many other things to do, and why fix what's not broken? It's been working fine for you, and I agree with that to some extent. I hate to spend a lot of time, effort, energy to fix something that's not broken. That makes sense to me, but there might be other reasons. So Greg, let's put up poll question number 1.
Okay, that's launched, and we'll let people take a few seconds here to answer that, and then I'll read back the responses and give everybody a chance to chime in here what their reasons for still running 2008 are. All right, we got a good amount of people voted so far. I'll just give another 5 seconds here, and I'll show the results.
Yeah, right.
All right, let me close that down and share. So 61% said legacy applications require it. 34% never have the time to upgrade. 20%, 21% is other, and 10% costs too much to upgrade.
Great. Yeah, and that makes a lot of sense. It really does. You know, the whole legacy application thing. That's kind of you can't get around that. You know, if you have a legacy application and you know, maybe that application, that vendor, you know, isn't providing updates, or you don't plan to update that application, and you're kind of stuck with this, you know, this instance or multiple instances of SQL 2008 that you have to keep hanging around. So here you are. What are you going to do with that? And so you want to make sure that, you know, at least for an additional 3 years, you don't have to worry about it. So kind of pushing the problem down the road a little bit. So what are your options to upgrade to newer SQL version? Well, we just said we can't do that for one of many reasons. So you could, you know, when thinking about the cloud, you can rehost your, you know, this is what Microsoft said. If you read the, you know, kind of the marketing material, it's like, well, just rehost your SQL 2008 or 2008 R2 and SQL Azure Managed Database for a version-free platform. Well, chances are, if your application vendor is not going to support SQL 2012, they most certainly aren't going to support, you know, running as an Azure SQL database either. Or they say, you know, move to Azure virtual machines. That's what I kind of talk about today, is basically leveraging, you know, Azure infrastructure as a service. And so you're basically going to manage your own virtual machines in Azure. You're going to install SQL, and you're going to run it up there in the Azure platform. And that's kind of the message I got from Microsoft at Ignite, and listening to presentations and visiting the booth. It was like, oh, well, you know, Microsoft's really kind of forcing our hand here to get these VMs up into Azure if I want to get this extended support. But in preparing for this webinar and start reading some of the documentation and some of the announcements, they say you can continue protection beyond the deadline by up to 3 years of extended security updates. Only covers workload, right? So basically, what they're saying, you could pay for to keep giving these updates without doing anything. So there's always that option as well. So here's exactly what they are saying, that, you know, if you have active software assurance or subscription licenses, you can purchase extended security updates for 75% of the enterprise agreement license cost annually. And then you just buy for the servers that you need. So you really, you know, it's not as dire as, you know, you might think, and you don't necessarily have to move your SQL 2008 to Azure. But there's good reasons why you might want to move it to Azure after all. Before we do that, let's Greg, if you pull up the poll question number 2.
All right, there it is. So the question, what are you going to do with your SQL 2008 instances? And again, we'll let people vote on these, and we'll share the results.
Yeah, that might be news to some people if you hadn't done any of the research and you're just reading the headlines, that, well, you could just buy the extended security updates. I'd be curious to see who's just going to go ahead and do that.
Give another 5 seconds and I'll share these results. All right. So we have 66% said upgrade, 38% move to Azure, 18% roll the dice, and 12% said pay for the extended security updates.
Yeah, that's good. So I mean, upgrading is always probably your best option if it's an option for you. But that's interesting. Okay, so let's assume that you're here at this this webinar. So obviously you're maybe considering it, even if you didn't say you're gonna move. You're kind of interested in moving to Azure. So why what are some of the reasons why you might want to move to Azure? Infrastructure as a service, and so we talked about platform as a service, the Azure SQL database. Probably not going to work out for you, so that's not going to be a fit. Staying on premise, as you just learned, is an option. If you have software assurance and you want to pay for the enterprise agreement license, you might, all those instances might be running on some old hardware, which you need to refresh. So, there's a cost associated with just running it in your own data center, potentially with, keeping your hardware fresh. And of course, the whole reason, moving to the cloud is getting out of the, data center management. You might be looking for, moving some of your workload to the cloud anyway. So this is a good, reason to take some of your workload and start testing out the cloud if you're not already there. But in addition to that, the cloud, you have potential for some performance improvements and as well as availability improvements. And we're going to focus a lot on the availability options you have in the cloud that you might not have on premise. So you're going to have some very robust HA as well as DR options by moving your workload into Azure. So high availability and disaster recovery in Azure. If you read the SLAs, there's two SLAs out there now. There's the first one, and we're going to go into a little bit of detail over these options here. This one's been around for a while. The 99.95% service level agreement with fault domains. And we'll talk about what fault domains are, but essentially a fault domain is putting your two instances of SQL in different racks within a single Azure database. And then you're going to have to do something to keep the data in sync between them. So we're going to talk about building a failover cluster or potentially, using database mirroring. And if you do that and you have two servers in different racks or different fault domains, Microsoft will give you 99.95% SLA. But the new option that's just rolling out and available, I think it's in about 6 or 7 regions now, availability zones where within, and again, we're going to have some detail here, but essentially, within each region in Azure, in some regions, they're having multiple data centers miles apart from each other that give you a little bit more redundancy should a single data center have a failure, which we just saw in September. There was a multi-day outage in the South Central region. It's pretty bad. With these availability zones, you would have been able to survive that outage. And so if you deploy across availability zones, Microsoft's going to give you the 99.99%, which is a lot better. So basically, guaranteeing that you're going to have very minimal downtime if you take our advice and deploy across availability zones. So for high availability, there's a bunch of options, but for disaster recovery, we're going to look at Azure Site Recovery and replicating your instances across geographically dispersed data centers. So not only, miles away, but hundreds of miles away. So you're going to really have protection from natural disasters. And people think, well, if I have an entirely different data center and, these data centers in availability zones are different floodplains and different power grids, so there's a lot of resiliency. But, just look at the wildfires happening in California right now or the crazy hurricane season we've been having. You can imagine a scenario where, you might have some kind of natural disaster that impacts an entire region, even across availability zones. So you want to have a plan B. So we're going to look at how you can have recovery in an entire different region as well. And we're going to do that through using Azure Site Recovery, which is kind of a real-time replication of your entire instance. It's going to give you your best recovery point objective and recovery time objective. And of course, Azure Backup is a simple backup cost-effective solution that you can use within Azure as well. So that will supplement, and that gives you the ability to store much older copies. So when you do a backup, typically you back up your data. You might use, store a monthly backup forever, and then a weekly backup. You want that past 4 weeks maybe. So you have a lot more options to restore from older points in time if you need to. So all that's baked right within Azure. So these are, tools that you might normally spend a lot of money on if you go out to buy some, backup software, that can get expensive. And all this is relatively inexpensive, running, just these services that Azure offers, software as a service, right? And then when we talk about high availability, we talk about failover clustering, primarily with SQL Server 2008, R2 and earlier. That was prior to the days of the always-on availability groups, which was introduced in SQL 2012. So before that, really the only truly high availability option was failover cluster instances. And the failover cluster instances assumes that you have some sort of SAN, some sort of shared storage device, which is not available in Azure. So in the Microsoft documentation itself, it says if you want to build a failover cluster instance in Azure with SQL 2008 R2, really the only option is to go get some SIOS DataKeeper, and that's primarily why I have so much experience with this, because we help customers build clustering all the time. So we'll take a look at that, as well as the HA solution for your SQL Server 2012 instances. So talking a little bit more detail about fault domain. So this has been Microsoft Azure's recommended solution for high availability for since the beginning. And so again, a fault domain is really, you can think of this pictured here. We have three fault domains. We have FD0, FD1, FD2, and each region minimally has three fault domains. And so if you put your instances, and we'll look at this in the live demo, if you put your two SQL instances that you're going to use in your cluster into what Microsoft calls an availability set, then it will distribute those instances into different fault domains. So to put, the primary server in fault domain 0, your secondary server in fault domain 1. And the reason why the third fault domain is so important is that if you're familiar with failover clustering, there's this concept of a quorum and witness. Now, in a traditional shared storage cluster, you most likely will use a disk witness, but because there is no shared storage, you're going to want to leverage a file share witness. And so the file share witness would have to reside in fault domain 2, this third fault domain over here, to ensure that the failure of any single fault domain would only impact one vote of your cluster. And so Microsoft takes care of that for you automatically, assuming that you put not only your two cluster nodes, but also the server that's running your file share witness in the same availability set. Microsoft will distribute it across fault domains. But not only fault domains, Microsoft has this concept of an update domain. So if you think of the three fault domains as racks of servers, and then the blue and purple boxes as actually physical servers in that rack that host VMs that you're running on, Microsoft also distributes your instances across multiple update domains. And an update domain is essentially Microsoft will guarantee that if they ever have to do a patch that requires a reboot of a physical server, which might bring down your VM, they will only reboot one update domain at a time. So if you have a cluster configured and they reboot the server hosting your cluster, you will fail over to the remaining server, which is going to remain up and running. So that's how Microsoft has handled it traditionally. But as I mentioned, they've come out with this concept of availability zones, and this has been around for a while. If you're familiar with like AWS and how they do availability, they've been doing this. This is kind of the way AWS has been handling it all along. So Microsoft is building out additional data centers within the same region, but separated. They don't exactly say how far apart. I've seen some maps that indicate kind of like maybe like a 10-mile square radius. But again, I can't find anything official from Microsoft on that. But these data centers are well connected, and meaning that fiber, low latency network connections, so that even though they're different data centers, one of the benefits of I would say of Azure over AWS is that not only are they well connected with low latency, but they're also can be a single subnet, which, if you're familiar with clustering, is important, and especially for SQL 2008 R2, because Microsoft did not start supporting multi-subnet clusters with SQL Server until SQL 2012 or later. So you have to have a single subnet if you want to cluster SQL 2008 R2 or earlier. So thankfully, Microsoft was smart enough to, when they designed availability zones, your VNet or your virtual network can span multiple availability zones, so you don't have to have different subnets. So that's going to make our life a whole bunch easier when we think about how we're going to build a cluster with maybe one node in AZ1 and one node in AZ2. And once again, you still want to put your file share witness in AZ3. So Microsoft was smart enough to decide to have at least 3 availability zones in each region. And there's a list of currently supported other regions that currently support availability zones. In the states here, Central US is online, and West US 2 is online. East US 2 is available in preview, and in Europe you have some options. So they're lighting up new ones all the time. I think West US 2 was the most recent announcement I saw. So you want to check out your regions. If you have a choice, I would suggest that you do this. I would suggest that you find a region that supports availability zones if you can. Let's go ahead and put up the next poll question, Greg.
All right, so the question is, what do you do today for SQL 2008 HA? I got a good amount of people voted already, so we're just giving us a little bit more time and share the results. I get under 5 seconds here. All right, so we have 52% said failover cluster instance, 32% hypervisor, VMware, Hyper-V failover, 20% other, and 17% said database mirroring.
Okay. Yeah, so about half failover cluster instances, and that's expected. I probably should have asked, well, maybe the other is we don't really do anything. We do some good backups, which is, that's perfectly fine in many scenarios, depending upon, how business critical this application is, right? Some instances, if you're off for a day or whatever, it's not the end of the world, versus other instances, every minute you're down, you're losing money. So I'm imagining a lot of the other is probably, we don't really do HA today. And, when you think about it, that was fine on premise for, some of your workloads, especially because, you managed it and you were, you controlled, what was happening with the host and, when maintenance was going to happen or if maintenance was going to happen. And so you could kind of control your own destiny there. In the cloud, you might want to rethink that because, Microsoft's not going to guarantee you anything if you just put a single instance in the cloud. And you're definitely going to have downtime due to maintenance. Microsoft made that a little bit easier in that they, make some announcements of when maintenance is going to happen, and you can, pick and schedule the time within a time frame of when you want that maintenance to happen. But, running a single instance in the cloud is not generally advisable, again, unless it's just really not all that important to you. So good information. And of course, everyone doing hypervisor, VMware HA, or Hyper-V failover, that's great for on-prem, but now when you move into the cloud, Microsoft, they're not doing that for you. They're not going to fail your VM from one availability zone to another. You have to take some action on your own. Otherwise, you don't qualify for any service level agreement if you're just running a single instance. So you are going to have to consider, building out SQL Server failover clustering instead of leveraging VMware HA, which is not going to be something that you can do in Azure, obviously. So let's check this out. So let's assume that we're moving to the cloud, and our best option is going to be failover cluster. Build a SQL Server failover cluster in the cloud. The OS support for SQL 2008 and 2008 R2 in Azure are listed here, so we can run Windows Server, Windows 2008 R2. Now, again, Microsoft is extending support for these older versions of Windows as well. If you are running in Azure, so you're going to get the 3 additional years with your Windows Server 2008 R2 as well. Windows Server 2012 or 2012 R2 are all options that will run in Azure today. If you are going to pick 2008 R2 or 2012, you're going to have to download a hotfix, and the link is at the bottom of the screen here. Basically, it's going to update failover clustering so that the IP address can listen to the probe that we're going to talk about later. But make sure you get those updates. I would recommend that you run 2012 R2. That's going to give you your best, I think, your best performance. It's going to be the most reliable. Hopefully, your vendor is not locking you into Windows Server 2008 R2. But if so, it works. It's out there. It's supported. I built it, and it's fine. But if you can upgrade to 2012 R2, that would be my recommendation. We mentioned this earlier. There's no multi-subnet support, so fortunately, we're going to be able to build clusters in different fault domains or different availability zones in the same subnet. That's not going to be an issue. Configure the internal load balancer for client redirection. So, this is kind of a checklist of things that you should investigate further. But if you've ever built any sort of high availability cluster in Azure, whether it's a SQL Failover cluster instance or availability group, or if you've read anything about it, you've probably heard people talking about the internal load balancer. Really what's going on in Azure is that, and this is common with many cloud providers, is that the network does not support gratuitous ARPs. So what does that mean? It means that you can't connect to a cluster IP address as you normally would expect upon a failover, because the routing table doesn't get updated properly. So the way around that is Microsoft will have you configure an internal load balancer, and so your clients connect to the internal load balancer, and then the internal load balancer is probing the cluster nodes to see which one is active. And so it will redirect the client to the active node. So at the end of the day, it doesn't look any different. You don't manage it any different than you're used to, but up front, there's some configuration that has to take place in order for your clients to reconnect. So if you miss that part and you build a cluster, it's going to look like it's working, but you're going to get frustrated because your clients won't connect. So don't forget the internal load balancer. There's lots of documentation out there on that. So Microsoft's documented. I have a whole bunch of step-by-step guides on my blog, Clustering for Mere Mortals, so you can get some detailed information there on how to configure that. I mentioned earlier that there is no shared storage available in Azure, and SQL 2008 R2 and earlier did not support anything like hosting your data on SMB shares or anything like that. So really, the only option is the third-party solution SIOS DataKeeper, which we'll take a look at the end. Which essentially what DataKeeper does, it lets you build a failover cluster instance leveraging locally attached disk. So we've been doing this since 1999 when SIOS was founded. It's very simple. You'll see in the demo, but we just do block level volume replication synchronously between nodes in the same region or asynchronously across region. And then we integrate with failover clustering. So the cluster thinks it's a shared disk, but it's really controlling the mirror direction. So it's truly a failover cluster instance, but leveraging local storage. And we mentioned a file share witness. You're going to want to make sure that's in a third site, whether it's a third fault domain or third availability zone. I would normally in Azure recommend configuring a cloud witness, but that wasn't introduced until Windows 2016. And I'm not even sure. I don't think SQL 2008 R2 is supported on 2016. But if it is, yeah, do that. But I'm pretty sure it's not. I could be wrong, but check that out. All right, so let's take a look at, if you built a traditional cluster, you're used to you're familiar with this picture. You have two or more nodes connected to shared storage. That shared storage, as I mentioned, is not available in Azure. So the SIOS DataKeeper solution is basically software that's going to run on each cluster node. So there's no additional infrastructure, no VMs you need to run or anything like that. You're just going to run a simple setup on each of the cluster nodes, and then you're going to build your cluster like you normally would. But instead of using shared storage, which is represented via a physical disk resource in Cluster Manager, you'll see something called a DataKeeper volume resource, and that takes the place of the physical disk resource. So when Failover clustering detects an outage, it will still fail over to the other node, but instead of controlling disk locking or the SCSI reservations, it controls the mirror direction. So now node 2 is the source of the mirror, and all the remaining nodes then become the target of the mirror. In Azure, it looks something like this. If you're leveraging fault domains, it's simply one server in one fault domain, the other in the second fault domain, and then your file share witness in a third fault domain. So it works just like it would on premise, but you're failing between fault domains or availability zones if you want to leverage the newest technology. So we talked about, high availability, which is very important, but not only high availability, as we mentioned with the wildfires raging in California and hurricanes, it seems every other week. And I look out my window, the snow's already coming down here in New Jersey. So the weather has just kind of been crazy, and I think we're going to expect more of the same. So we really want to configure something for disaster recovery. So let's go ahead and put up the fourth poll question if we could, Greg.
All right, so the fourth question is, what do you do for SQL 2008 DR today? And again, we'll give you all a chance to vote, and I'll share the results. Another 10 seconds here. All right, get those last votes in. All right, let's share those. So we have 56% said backup only, 32% log shipping, 18% database mirroring, 10% other, and 8% multi-site cluster.
Yeah, that's good. Well, of those, log shipping, that'll be around forever, right? I don't see that ever going away. So you can continue to leverage log shipping if that works for you, and you're good with the recovery time objective, recovery point objective. I'm thinking about if I've had a disaster and I'm running there, how do I kind of get back to my primary site? You got to take all those things into consideration with log shipping, but it is a free solution that is pretty well known, pretty rock solid for it does what it does, pretty very, very well. Multi-site clusters has always been a challenge with SQL 2008 R2 and earlier due to that subnet restriction. But now, effectively, when you deploy, if you deploy a failover cluster, as I said, between availability zones, you really have a multi-site cluster, but it's a single subnet. And database mirroring has been around. It's good for what it does. You can continue to leverage that as well. Or what we're going to talk about is the newest feature that you might not be overly familiar with, Azure Site Recovery. And we're going to take a look at it. We're going to demonstrate this as well in just a moment. But Azure Site Recovery is just another software as a service offering from Microsoft in Azure. You can configure this. And what it does, it really just replicates your entire virtual machine from one region to another region. So very much like if you do VMware SRM or any of the the Veeams of the world or anything that does like full server replication, it's a very similar concept. It's very cost effective. It's only like $25 a month per VM, and it works very well. It's very easy to configure and manage. You're going to get a recovery time objective of about 3 minutes if you click on the button to restore. It basically provisions the VM and starts it up, boots the VM. So you can imagine how long it takes your VM to boot and to come back online. Your recovery point objective is something you're going to want to keep an eye on. Microsoft will give you, say seconds, 30 seconds, or whatever it might be, but really it's going to vary greatly depending on your rate of change. So how active is your server? And it has an upper limit. So Microsoft will publish this upper limit of 10 megabytes per second of rate of change. And if you exceed that, then essentially Azure Site Recovery is not going to be an option for you. So you're going to definitely want to keep an eye on that. But assuming that you are, within the rate of change, it is a very cost-effective, robust DR solution that also is very it's easy to do DR testing without impacting production. So we'll take a look at that as well. And this is what it might look like if you were configuring it. You're gonna, obviously you want to have high availability. So DataKeeper has been certified with Azure Site Recovery. Microsoft, took us in, I think, in 2017 and did a bunch of testing and talked about it at Ignite in 2017. So you can build a failover cluster instance with DataKeeper and then leverage Azure Site Recovery to replicate the entire cluster pair from, in this case, from Azure Central to Azure US East 2. And you can do that not only for your database tier, but for your application tier as well. So anything that you want to replicate, you can use Azure Site Recovery so that you have a duplicate copy of all your VMs ready to go in another region should there be any sort of extended outage. And let's talk about regions. This is a map of 54 regions worldwide in 140 different countries. I'm sure you can't read this, but this is available on Microsoft's website to show the regions. But what you really want to be concerned about is something called a region pair. So once you pick your region, you're going to want to look in the Azure documentation to find out what is my paired region. So and why does it matter? Right. So region pairs, whenever possible, are in the same country, so your data doesn't leave the country. And what a region pair does, one thing it does is isolates you very much like a fault domain we talked about earlier. I'm sorry, an update domain, where Microsoft, if they're rolling out any sort of updates in a region pair, and let's, for instance, I think Central and US West, right, it might be a region pair. If they're doing updates in Central, they're not going to do those same updates in US West until Central's been updated and there's no known issues, nothing, everything went smoothly, and only after that would they update your paired region. And that way, if there was some, and like this will never happen, no, it happens quite too often, it's happened in the past, where an update didn't go quite as planned and caused downtime in that region. So if that happens, you can be sure that the region that you're replicating your VMs to should not be impacted. So you can actually recover in that region, if there's any sort of extended outage in your primary region. Region recovery order. So let's think something really went bad that impacted multiple regions, and this is probably more user error than natural disaster error. But if there was some, something got, some snag happened and multiple regions went offline, like it's really a bad day at Microsoft headquarters. Well, they're going to prioritize at least one of your regions for recovery. So instead of just, haphazardly, trying to recover as many regions as quickly as possible, they're going to pick half of them and say, okay, these half are our priority. We got to get at least one region pair up and running as quickly as possible. So they're going to focus their efforts on recovering at least one of your region pairs so that at least you have something, whether it's your primary region or your secondary region. You can't really decide that, but they're going to recover at least one of your regions as quickly as possible. And the region pairs are going to hopefully give you enough distance to isolate you from the natural disasters we talked about. So typically, whenever possible, they're greater than 300 miles apart. And so when you're configuring your DR, that's the most important thing. Is if you weren't aware of region pairs, you want to do the investigation, and they're all published in the Azure documentation of what regions are pairs. So definitely check out the region pairs. So I'm going to shift focus here for the next 10, 15 minutes, and then we'll take some questions at the end. So if you have questions, submit them online, and we'll allow some time at the end to answer your questions. So I'm gonna wing it today, and actually I usually record demos, but I'm gonna go out here to an actual live functioning Azure portal, and I'm gonna do a couple things in case you haven't used Azure before. Maybe I'll start with the most new thing that I'm pretty sure not a lot of people have played around with yet, and that's the Azure Site Recovery, or ASR for short. So I have some, and then later I'm going to provision a VM and show you how to pick, like regions and fault domains and that kind of stuff. But I have some virtual machines running here, and some SQL 2008 R2 clusters and whatnot. So I'm going to just pick one of mine. Let me see. I kicked something off earlier. Let me double check something before I do this. Let's see if this is happening. I've replicated one of my VMs. I want to see if it got replicated. Secondary help be protected. Awesome. So I did the secondary server. So I already replicated my secondary server. So I'm going to show you how I did that, and I'm going to show you how disaster recovery works. So let's go back to the VMs. And here's my primary server, right? So if I go to the primary server, I can go down here to disaster recovery and click on disaster recovery, and it basically says, okay, so let's go back one second. This primary is running, you see, in central US, so I have it running here. I have it in an availability zone, and that's actually good. I'm going to jump to this portal. So availability zones, again, are the newest high availability feature in Azure, and so I have, if I look at my instances, I have these instances running in different availability zones. I have the primary running in AZ2, the secondary running in AZ3, and this is all in central US. I have my domain controller in AZ1, and that's also acting as my file share witness. So this is an optimal configuration. And I'm actually running a preview portal to light up a feature that's going to be, they announced at Ignite, and they gave me permission to talk about it here today. We're going to not only replicate all these VMs to an entire different region, but we're also going to be able to specify in that other region what availability zone to put it. So even when you're running in DR, you're going to have HA. So this is not, if you look in your portal today, this is not available to the normal public, but you should see this coming out in the portal very soon. So once again, we'll go to the primary server, and if I go down to disaster recovery, this is how I'm going to configure disaster recovery for this primary server. So what's my target region? So because I'm using availability zones, obviously I want to make sure my target region supports availability zones. So East US 2 is in preview, and I have access to that. So I'm going to choose that as my target region. And there's some, it tells me all about the source, from my subscription. I'm going to use the same subscription. My resource groups, I'm going to have it create this central ASR resource group for me. Same with the virtual network. It's going to actually create a virtual network over there for me. And this is the new thing. So in the source, you see it's in availability zone 2. When I recover in US East 2, it's going to be in AZ 2 as well. So this is new, coming out shortly, and so being able to specify that is good. But that's that's it. You can some of the replication settings, the policy by default it stores 24 hours of snapshots, which we'll see. You can increase that up to 48 hours. If you want to go beyond that, then you have to start looking at third-party solutions. But typically, 48 hours is a pretty good time frame to recover, point-in-time snapshots. Anything older than that, it's more cost-effective to do backup if you need to go back to something older than 48 hours. But that's it. I do that. I click Enable Replication, and it goes off and starts doing that. It takes some time to provision the job and then actually do the replication. So I'm going to jump back to the regular portal and show you how that VM that I replicated earlier, if I look at the Recovery Services Vault, this is how you manage the recovery services. I have that VM we looked at earlier under my replicated items. I have this, you can see this primary is already enabling protection, right? The secondary server I replicated earlier, replication health says healthy, status protected. That basically means it's fully replicated, ready to go should I have a disaster. So if I want it to fail over, I can actually do a real failover, and by doing a real failover, it will provision the VM in whichever network I say I want it to be provisioned in, and that's great for a real disaster. But most likely, hopefully you never have to ever do that. But a lot of times you just want to test failover. This is really great. I could choose test failover. It'll say, tell me failover direction. Of course, it's already decided for me because I picked that when I replicated these. So it's going to fail over from central to east, and it lets me choose a recovery point. I probably don't have a bunch because, like I said, I just started this replication about an hour ago. So I only have a couple recovery points. But again, you would have up to 24 hours of recovery points. And you notice one says app consistent and the latest process. So they give you the ability to do application consistent snapshots. I think like every 5 minutes. So about every 5 minutes, you can have some VSS integrated snapshots that will give you application consistent snapshot. Or if you want to recover from the latest replica, it's going to be a crash consistent copy. So and typically that works just fine. I never really have any problems, doing crash consistent replicas. So you might want to choose the latest, and then again, pick your Azure Virtual Network that you want to recover from, and this is the one they pre-provisioned for us, and click OK. So what this is going to do is, and we'll come back to this in a minute, this is going to actually provision that VM in that VNet, and that VNet is isolated from your production network. So I'm not going to have any name or IP address conflicts. So it's very nice, and we'll look at this VM in just a moment that's being created in the background. It's a very easy, simple disaster recovery test, and it hasn't impacted my ongoing production system, right? So while that's cooking, the virtual machines. Now, okay, so we're going to talk about this. So what are your options, for migrating into Azure? So you have two choices. So Azure Site Recovery can replicate between regions in Azure, but it can also replicate from on-prem into Azure. And I don't have that, I don't have a system set up to do that, but it's pretty well documented. And whether you're running physical servers or you're running in VMware, I think support VMware or Hyper-V virtual machines on premise, any one of those platforms, you can actually leverage Azure Site Recovery Manager to replicate your on-premise instances into Azure. So it's kind of a lift and shift. So if you want to take everything that you have and just turn it into an Azure-based VM, you can use Azure Site Recovery to go from on-prem into Azure. That's an easy way to lift and shift. The only problem is you'll encounter is if you have your failover cluster instances on-prem with that shared storage. We mentioned shared storage is not supported in Azure, so you're going to have to do something to address that. And I documented in my blog, but essentially if you want to do that, you're going to have to convert your shared storage cluster on-premise to a SANless cluster based on DataKeeper, and so it's kind of a process first to convert it from a shared storage to a SANless cluster, and then once you have it as a SANless cluster, then you can use ASR to move the entire cluster into Azure. So that would be one way. Or you might consider, well, let's just build a fresh cluster. That gives you the chance to do some testing and whatnot before the actual migration. And then you can just simply, schedule some downtime to do a backup and restore into the new cluster running in Azure. So they're really your two options. There's, pluses and minuses for each. But once you're up here, if you want to build, if you've never, built a virtual machine before in Azure, it's a pretty simple process. So I just want to point out some of the high availability features here. So you create a new virtual machine. You're going to choose your resource group, your virtual machine name, all that good stuff. Availability options. So here are your options. So availability set, because I chose, let's see, Central region, East US 2. Let's choose Central US. I should have. Yeah, so by choosing a region that supports availability zones, now I have two options. So if I want to leverage availability zones, I would choose this. And then I can specify which one of the three availability zones I want, right? And that's the newest thing. I would recommend that if possible. If you can't do that, then the old way is choose availability set. And because I haven't created an availability set yet, I would have to create a new availability set first, and then make sure as I create my second VM and my file share witness, if I put them all in the same availability set, that will distribute the VM over to that would that I lost my train of thought here. So that would make sure your VMs are distributed across the update domains. I had a failure, and that's always a problem with live demos. I don't know why. I have to investigate to see why that SQL Server instance didn't start. So I'll have to check that out. But anyway, I think I want to take the next 6-7 minutes to answer any questions. Again, this is kind of a lot of information in a short period of time. If you have any questions, you can contact me afterwards, and we'll put up some contact information. All this is pretty well documented in Microsoft's website or my blog, Clustering for Mere Mortals, has a lot of this information with some step-by-step guides. So, Greg, do we have some questions in the queue around this topic?
Yep, there's some questions, and before we get to that, I'm just going to pop up another poll question that I'm going to leave up while we do the Q&A. So one question that came up was, this just seems really confusing. There's so many different layers. I'm just wondering, is it really that confusing to get this set up, or is it pretty much make sense once you get going with it?
Yeah, well, so the failover clustering in general, if you've never done it, it might seem that just that alone could be overwhelming if you've never done it before, right? It's really not. Microsoft has made it pretty simple to do. As of Windows Server 2008, clustering is pretty easy, and that's why I started my blog, Clustering for Mere Mortals, because it can seem overwhelming, but in reality, it's not. So you got to get over that hurdle first, right? If you're familiar with clustering, then the additional things you need to worry about is comes down to the networking and the internal load balancer that I mentioned. And again, that's all pretty well documented, but it is a step beyond what what a traditional failover cluster requires. And the cloud has a lot of other concepts, so it really depends on where you're starting from. If all you've ever done is managed a couple physical servers in your data center, or even a small business, and you've never done cloud, yeah, I mean, this is a pretty advanced topic to be your first thing that you're tackling. So you definitely want to become familiar with cloud in general, provision some VMs, get some storage provision, play around with networking and firewalls. And Microsoft makes it easy. You can get some free credits, some trials to you definitely want to be familiar with cloud. But if assuming that you got some knowledge about the cloud and some knowledge about failover clustering, it's not that difficult. And again, I'm here. I'll be glad to answer any questions you have. And if obviously SIOS is sponsoring this session, and we'd love you to buy some DataKeeper to build out your failover cluster instance. So if you're doing that, I mean, I help out the pre-sales process personally. So I'll make sure that I answer any questions you have, and we'll get you up and running quickly for sure.
Okay. Another question somebody had was related to, is there any way to test this stuff in Azure, or is it everything you got to pay for it? Do they offer any free credits or anything that you can kind of get going and starting?
Yeah, I know I have free credits through my MSDN subscription. I haven't looked lately. I'm pretty sure that they do, offer some free credits just for signing up. So definitely check out Microsoft. I'm pretty sure just the average user with an email address can get some credits to check it out. So look for that. So I'm pretty sure that's available.
Okay. Let's see. Another question somebody has just related to, is there any quick start or quick way to get something implemented for clustering or even using DataKeeper within that?
Yeah. Right. So in Azure and most cloud providers have something similar as quick start. So in Azure, they use GitHub, we call deployment templates, deployment templates. So there is a DataKeeper. SIOS publishes a deployment template that will automatically go out and build you a 2-node. I think it's a SQL 2014 2-node failover cluster. It does everything for you. Basically, you fill out administrator name, password, pick the region, pick the instance size, click go, and go have lunch, come back, and you have a 2-node cluster configured for you. Now, for 2008, I'm not aware of any automated deployment templates. Again, it's kind of an old, platform, so, there's not, there hasn't been any investment in building those deployment templates. But if you had to do this for, 100 clusters, I would probably learn how to build build your own deployment template so that you could automate this process yourself. And that's that's really the beauty of the cloud is if you invest a little bit of time up front to automate your processes, then you're going to save a whole bunch of time on the back end because you can just push a button and, there's another cluster, and you didn't have to do all, reinvent the wheel every single time.
Okay. Another question that came in is just about your URL to the website or articles. Can you just kind of reiterate what that is again?
Yeah, so my blog is Clustering for Mere Mortals. I'll bring it up. Make sure you get this SIOS contact information here, right? You can get us on us.sios.com. And my website is Clustering for Mere Mortals. That's my blog. And again, I write about mostly cloud, high availability, but a little bit of everything. So if you search the website for like Azure, Azure cluster, you'll come up with a whole bunch of articles on clustering Azure. So anyway, that's the blog, clusteringformeremortals.com.
Okay. Let's see. Another question, Dave, is related to if somebody wants to keep their databases on premises, but then use the cloud for HADR. Is there a way to set up a cluster and replicate data between on-premises to the cloud?
Yeah, so ASR does not support traditional failover clustering with shared storage. So, normally, if you have a single instance, you can certainly use ASR from on-prem into the cloud, and that's a great, way to, leverage Azure as your disaster recovery site. If you wanted to do that for your cluster, just like I was saying earlier, you would have to basically convert your on-premise cluster to a SANless cluster, and then you could use ASR to replicate the entire cluster. Obviously, newer versions of SQL, you can do the same thing, with your cluster. Or if you do availability groups, obviously you can put another replicate in Azure and make it an async replicate. You can do that. So there's lots of options for using Azure as a DR site.
Okay. And the follow-up that somebody asked, is it something DataKeeper could do too, or do you have to just use the Microsoft tools?
Yeah, so DataKeeper, absolutely. You can replicate, you can add a third node to your cluster and have that third node in Azure. And DataKeeper could do, replication from the on-prem cluster into Azure for disaster recovery. So that can work in one of two ways. We do support a shared storage cluster locally, and then just have a third node as a replicate target. And that's going to give you basically your best recovery time objective and recovery point objective in comparison to, like ASR, where we saw, could be minutes behind. We're typically milliseconds or just a few seconds behind at any given time. So it's a very robust DR solution.
All right. Well, that's it for questions. So, Dave, can you just go back to that last slide that has the contact information for people to get more info?
There you go. Mm-hmm.
So there you go. So if you have more information that you need, you can get in touch with SIOS from those different, from the email, phone numbers, go to the website. There's a bunch of white papers and other information out there. So definitely visit the SIOS website after the webcast today. So at this point, we're just going to wrap things up. And I want to thank Dave for sharing that information today, and also thank SIOS for sponsoring today's event. The webcast was recorded, and you'll receive a follow-up email with links to view the archive, and we'll hopefully get a copy of the slides from Dave that you can download as well. Also, please visit mssqltips.com to access all of our free SQL Server resources. We have a bunch of upcoming webcasts, so check those out, and they're all free, so sign up, and hopefully we'll see you in the future. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.